Hello, this is Susan Poss. We're working in section 10.5, which is working with parabolas. And we've spent a lot of time talking about finding zeros and finding the vertices of these various parabolas and how this vertex can be a maximum point if the parabola opens down or a minimum point if the parabola opens up. So now we're going to put that into practice by actually looking at two types of word problems. This first one deals with trying to maximize revenue. So I've set up the definition for revenue here. Revenue is the number of items sold multiplied by the price per item. So here we have a hot dog stand selling hot dogs for $3 each. And they average selling 2,000 hot dogs per game when they do this. They want to maximize the revenue, so they will consider raising the price per hot dog by 25 cents per item. However, they have determined that raising the price will reduce the number of hot dogs sold per game by 100 hot dogs per each 25-cent price increase. Find the best price to maximize the revenue. So I find the best way to get started with this one is to just try some numbers. So the definition says it's the number of items sold for revenue multiplied by the price per item. So currently, they are selling 2,000 items at a price of $3 each. So their current revenue is $6,000. Now let me get my calculator handy because we're going to just play with a couple of numbers here so that you can understand the problem. So let's see. What if they increase this $3 by one increase of 25 cents? So that'll bring the price to $3.25 per hot dog. But then the items, the number of items sold, will be reduced by 100, and I'm going to do times 1 because we just did one 25-cent increase. So that brings the number of items sold down to 1,900. It brings the price up to $3.25. And let me go over here to my calculator and multiply 1,900 times $3.25 per item, and I get $6,175. All right, so if we compare that to where they are now, that would mean more revenue, wouldn't it? Okay, so let's try another combination of numbers. What if they take this $3 price tag and they increase it by 2 increases of 25 cents? So that would bring this price up to $3.50. That would then bring this down by 100 times 2, 100 times each of those 25-cent increases. So that brings us down to only 800 sold. So, 1,800 sold. And that, whoops, I multiplied that wrong. Let me try that again. That brings me to 6,300. Okay, so that's still higher, getting higher there as I increase the price. So there's going to be a sweet spot. Let me see if I can do one more for you. Let's say they take this $3 and they increase it by 25 cents 5 times. So that would be an increase of $1.25. That would bring this up to $4.25 per hot dog. What did I say? 5. I said 5, didn't I? Yes, 5 for $1.25. So this would come down by 500. We'd be down to only 1,500 hot dogs sold. And let me grab my calculator again and multiply 1,500 times $4.25. And you can see that that is $63.75. Well, that's still higher than what we were working with. So what we're going to be trying to do here is to find what I call the sweet spot. We're trying to figure out how much price increase can we put in here and come up with the maximum revenue. All right, so let me go back over here. Let me get rid of all of this. I hope you have kind of an understanding now of the numbers and what's going on. Let's see if we can come back and write an equation that fits the circumstances of this problem. All right, so here's revenue. The number of items sold was 2,000. And the price per item was $3. All right, so what we're thinking about doing here is that every time we increase by 25 cents on the price, we're going to lose 100 hot dogs sold. So what is X going to represent? It's going to be the number of increases of 25 cents. So as you saw earlier, if I increase by 2 increases of 25 cents, I'm increasing by 50 cents per price. So I'm going to put the times X here, and then this number of items sold out here comes down by 100 times the number of 25-cent increases. So now I've got my equation. And I'm going to just do some work here. So I hope you see FOIL. First times first. Outer. Inner. And last times last. Oops, I think I have a sign error there. I think that should be a minus. Yep, it was a minus 100x times positive 0.25x gives me negative 25x squared. All right, so I see a couple of things here in the middle that are like terms. So you can see we have a second degree equation, which is what we've spent multiple videos talking about, is how to work with these second degree equations. I'm going to turn some things around here to remind you the lead coefficient here is negative. And of course what that tells me is that this parabola is going to open down. And this thing is going to look something like this, I think, when we graph it. What I'm going to be interested in is this point right here. I want to know the coordinates of that maximum point because those coordinates are going to be in this order. The first one, the x, is going to tell me the number of increases of 25 cents. And the second number is going to tell me the maximum revenue. Because you can see the equation over there leads off with the letter R. That is equivalent to the Y value. So R is the Y position, the Y coordinate, and X is going to be the number of increases of 25 cents. So I'm looking for the vertex. And you have a couple of ways. You can do completing the square. You can do the little formula. I'm going to use the little formula. So X, negative B, all right, B is the 200, over twice A, that's the negative 25. And that looks like 4. So what does that mean? I'm going to need 4 increases of 25 cents per item. And then let's go back and get y. And remember, the way you get y is you go back to the original function. Let me scroll up a little bit so I'm not running out of space down here. So this is, don't forget to square first here, this is 16. And I'm going to have to pick up my calculator again and multiply negative 25 times 16, and gives me my negative 400. So this number for y, that is the revenue. So let me write the coordinates down. If I make 4 increases of 25 cents, I will maximize the revenue at $6,400 per game. But the question, one of the questions is, what price is this? 4 increases of 25 cents. Well, I started with a price of $3, and I'm increasing by 4 increases of 25 cents. So it looks like the price, the optimal price should be $4 in order to maximize the revenue. Okay, so I'm going to stop there before I do the other type of problem. I hope that's going to help you work with maximizing revenue.